main purpose of Poisson distribution is we have to find the probability of occurrence in the specified interval of time or in specified interval of length. This is the purpose of using this Poisson distribution. Then when and where these Poisson distributions are used? This Poisson distribution is used when we have to find the probability of occurrence in the specified interval of time. So for example, if you take, if you are the two-wheeler man, if you have the two-wheeler stand, the manager have to find how many vehicles came within 15 minutes for past historical data, for past 5 days. They take some expectation, but today there is some problem in road, so that how to find the probability of coming the vehicle in this day. With the help of this probability distribution, we have to find it. And with the help of length, I specified the specified length. So in this case, if you have the more accident zone within the 10 kilometers, there is more accidents are occurring. So we have to find how many accidents have happened previous week, how many accidents are taking this week. With the help of this probability, we have to find it.
You talk about specified interval of time and specified interval of
Length.
Cannot it be specified interval of area or specified interval of something else? It has to be time or length.
Yeah, it's only time and length. Yeah, area also will be coming into
It can be anything. The span can be anything. It's not about length or time.
Area, mass, can be
Yeah, one second.
Interval should be same.
Yeah.
The interval should be same.
It's about interval. It's just about interval, not a particular instant. Whether it is length, time or anything, mass. It could be mass.
It should have exponential behavior.
Yeah, that is right. But I'm just saying you're talking about this
And it
length
should
and time.
satisfy the properties of Poisson distribution.
The properties, there is two properties. First thing, we have to take some incident. We have the one incident will be independent to another. The occurrence of one interval will be different from other. It will not dependent. It will be independent. This is the one probability. And next is the probability of occurring the event in one interval is entirely different from the another interval. Yeah, interval is same.
It is only not.
Both intervals are same, but the first thing is different.
Occurrence is different, but the probability
Difference is independent and probability
Probability
is
is different. Same.
So probability distribution function will be like this.
E power minus mu by x factor.
Here fx is a probability distribution function and x is a random variable. Suppose, and mu is the expected value or mean, and E is a exponent, which is a constant, and value of this is around 2.7. And if we plot a graph of this probability function on y-axis fx, and here we take x random variable on x-axis, then the behavior would be like this, exponential, because function is directly proportional to exponent, that is e, and this will directly give you the value of probability at x naught. Okay.
What is the meaning of exponential behavior in this?
This is exponential. Now we have
This type of curve isn't it same with the exponential?
Yeah, it is same. But difference is the exponential distribution will be for continuous random variables, and this will be Poisson distribution will be for discrete random variables. Discrete means it should have finite values or integer values 0, 1, 2, 3, and continuous we have in the interval, values will be in the intervals. Okay. We have two more formulas, actually one more formula for expected value and standard deviation.
Can you please explain what is mu?
Mu is expected value or mean. It is mean.
What? Mean
Central location of fx.
He's asking me
What is expected value?
Expected value of past historical data. So that we take the
Expected
mean.
value is a weighted average. You can relate it to the previous case when we have calculated the expected value of each decision alternative. The same is
Basically, expected value we can get from the historical data. Suppose you have started a company, suppose selling cars, and over the last 2 months you have sold about X number of cars. Okay, so but you have an idea that in probably a day you are selling approximately 10 cars. Okay, over a 2-month period. So basically, your expected value of selling cars for 1 day will be 10. That is what mu is. Okay, it's basically derived from the historical data.
the formula of expected value is summation of x into fx, where fx is the weight. It is weighted average. Fx is the probability of random variable x, and x is the random value of random variable, and the value should be from 0 to n number of trials, depends on number of value of that x goes. Okay.
Suppose from the historical data, we know that the average number of cars arriving in a 15-minute time period is 10. That is mu. And suppose if we want to find 5 cars arriving in a 15-minute time period, that will be x. 5 will be x. Sorry. So we will now put the value of mu as 10 in this formula, and the value of x, that is 5. If you want to find the probability of 5 number of cars arriving in a 15-minute time period, then we will have to put these values in this formula. So for finding out the value, we will see the table, that is x is 5 and mu is 10. So from the table we can get the value of f5 as 0.0378. So the average number of cars arriving in a 5 number of cars arriving in a 15-minute time period will be this probability.
Is it any 15 minutes? Like in 25?
Yeah, any 15
minutes?
Yes.
Sure.
Yeah.
So what was mu then? Mu was the average number of cars in 15 minutes time interval. And then in any 15 minutes, the probability of getting 5 cars is this thing.
I don't think it will be any time because if you look at
Anytime.
night,
Because here it is in Poisson distribution, and we know that the occurrence of any two intervals will be equal.
Okay, I'm going to explain a slightly complicated example. Suppose you have opened a fast food restaurant, and over the 2-3 months of operation, you have seen that in every 3 minutes, 2 customers are coming to you. Okay, so and then basically you have to find the probability that 4 or lesser customers will enter the restaurant in a 9-minute period. Basically, historical data shows that in every 2 customers are coming to your restaurant in 3-minute time period on an average. Okay, so basically what is the probability that 4 customers or less will be coming in a 9-minute time period? So according to the properties of Poisson distribution, we have to match the 2 time periods. Okay, so this is showing 3 minutes, this is showing 9 minutes. So what will be my the expected value of 9-minute period? So 6. So mu will be 6. Okay, and if we put the formula is in this case E is constant, we know the value, mu is 6 and x x is 4. ठीक है, x is 4 or less. So basically we have to find out the probability like this. Probability of exactly 0 plus probability of exactly 1 plus probability of exactly 2 Okay, so if we add all the probabilities, we'll get the probability of 4 or less people coming in 9 minutes. So basically the values will be like this. So basically, I am getting the value as 0.2851, which is equivalent to 28.5%. This much percent is the probability of 4 or less people coming in 9 minutes.
So what is the requirement of calculating individually and summing up? I can go for it.
I'm just telling you the differences between these two.
All right.
The first difference between binomial and Poisson distribution is that in binomial Poisson distribution, we basically use discrete random variables which requires a value from finite or infinite sequences. Like here it can take values like x is the discrete random variable in case of binomial Poisson distribution. It takes value 0, 1, 2, 3. It can be finite or infinite. And in case of Poisson, it takes value from an interval, from a range. Like it can be defined in this case, like x is greater than equal to 0, or x lies between -a to b or a to b, like that. So in this case, it is defined in a range or in an interval. Okay, and it can take any value between that range or interval. The second difference is that in binomial, the experiment is generally a multi-step experiment, in which we have two outputs. In every trial, we have two outputs. Like in case of toss of a coin, we have, for every trial, we have two outcomes. Like x can be success or failure, or head or tail. And in this case, generally it is a single step experiment. We use a Poisson distribution for generally a single step experiment. Okay. And the third difference between these two is that in binomial distribution, we have n identical trials. There is no mention about interval. There is no mentioning about intervals. One case of Poisson, we have trials for particular interval. They are same for only particular intervals. But their occurrence of their priority is same for a particular interval only. Okay. Like if I am explaining, if I am defining an interval from A to B, then occurring of an event in this interval is always the same. But if I change this interval from -a to b, then the occurrence of that event becomes changed. Okay. For example, like in a BPO company, I'm getting 48 calls per hour. Okay. So this is my range. This is my interval in an hour, and these are the calls. So here, if I need to calculate how many calls I'm getting in 1 minute, so I calculate it like this, like I'm getting 48 calls in 1 hour, that is 60 minutes. So in 1 minute I get 48 upon 60, this much. So this value, the discrete random variable values changes with change of the interval. Like I've changed the interval from 60 minutes to 1 minute, and its value changed from 48 to 48 by 60. This much calls. Okay. The next part will be explained by Ria, these similarities and the differences, by giving examples. So, Ria,
as we have seen that from our previous class, the formula of binomial is this, and as the previous group explained that the formula of Poisson is this. The main reason behind that in P, in binomial P is explained as the probability of success, and N is the independent number of trials. Whereas in Poisson, if we count there, it is calculated when P is very small, and the number of trials, that is N, is large. The main reason of calculating Poisson is this, that when we have P, the probability of success is less and the number of trials is more. For example, if we take in a lecture theatre G, in which we studied, the student, 5% students always come late. And if we take a batch of 100 students, and we have to calculate out of this, if we take 10 students, what is the probability that 10 students will be late? Getting my example? No. Okay. In the lecture theatre G, 5% of students always come late in a day. Okay. And if we take a batch of 100 students, fine. And it is seen that what is the probability that 10 out of 100, 10 students, what is the probability that 10 students will be late?
5% of 100 is how much?
5.
Calculate, put it there.
So I will do that.
Put it there, write it there. 5 are usually late.
Yes, sir.
Okay. You want to find the probability that 10 are late.
Yes, sir.
Go on.
So for this, we will move as like that. In this, that is the P, the probability of success is your 5%. That is 0.05, and N, that is the number of students, that is very large, and it is P, that is very small. That I explained that P should be Poisson. The reason we take that P is small and N is large. That is, it is 100. At the same said that in Poisson should be a finite value. That is P into N. That is this what we get. That is the value of NP, and this is what we gonna put over here. That is the mean. So we can say that. Okay. Now, when the student is at 10, the probability of the 10 students will be late in a trial of 100. In a trial of 100, what is the probability that 10 students will be late? It is like that. X is now 10, and our M is 5. We will put this X and this M in this formula, and we will get the value. Okay? Getting me? After that, the value which will be obtained by putting this value over there, that is like this. Okay? But now we can, it is seen that if P is smaller and N is large, we can see that if we can solve this question with the help of binomial formula also. The reason and the relation between this is that the P, then the probability of success is large in this and the independent trial is small. We can calculate this only. With this binomial, the main purpose of binomial, before solving any question, we should see that the probability of success is large or small. If it is large, yes?
Toss a coin. For example, you're saying that n is small. Suppose if n is very large, suppose we toss it about 100 times. So we cannot calculate using by binomial the success and
always 1 by 2. In case of you get the last probability as compared to the
Anika, Poisson especially for you, the P and Q for this should be less than 0.1. In a daily life problem, in a practical, the questions which we solve, it is from the different studies, it is less than 1, and the NP, that is this 0.1, and the NP should be less than 10.
I don't get it. The probability of success.
The probability of success
Should be less than 0.1.
Probability of success into the independent number of trials should be less than 10.
10.
Yes.
Why?
You can see from this example only. In fact, if you take any other example, the question which I have given, you take any other example, the probability of success into the independent number of trials will be less than 10.
So if it is greater than 10, then we say the probability is good or not good.
Probability will be less than 1 always.
What will happen in Poisson? You said in Poisson probability should be small.
So how do we know how much small, how much? If I want my business model to succeed, is this probability good enough? Is 0.5 good enough? Is it